When you have a Thevenin equivalent circuit and you want to find maximum power transfer, when you did this in DC, our Thevenin had to equal our load. For AC circuits, for maximum power transfer, Z load must equal Z Thevenin conjugate. You did this in lab. I don't know if you remember doing it. It was the week you guys used the capacitor box. Does anybody remember that? It's like 2 weeks ago. So if I have a Thevenin equivalent circuit and I want maximum power transfer, I need to let the load equal to the conjugate of the Thevenin impedance. What that does is it cancels out the reactive power or the inductor and capacitor. So it maximizes power delivery because it's purely resistive at that point. Yeah, questions about that? So the formulas become VRMS squared over RL or IRMS squared over RL for the power delivered to the load. Or in terms of V Thevenin, the magnitude of V Thevenin squared over 4RL. That should also look familiar to you, that it's the exact same formula we used in DC. The main difference is now, this is RMS. So there are a few special cases. For example, we saw when we did that capacitor box that it wouldn't reach the exact value we needed it to reach to cancel out the Thevenin imaginary part, the Thevenin impedance. So there are a few restrictions. So if you cannot completely match Z Thevenin to Z load or Z load to Z Thevenin, you try to match their magnitudes, or if you can't match their magnitudes, you try to get as close as possible to the square root of R Thevenin squared plus XL plus X Thevenin squared. If there are no restrictions on the load, then you try to match it exactly. So let's look at an example here. Example 1. We've done this problem already, so I'm going to give you the answers. We probably did this problem back when we did Thevenin equivalent. So we found that Z Thevenin was 6.25 with an angle of negative 51 degrees. We probably used source transformations to solve this. Okay. And I Norton is 1.79 with an angle of negative 63 degrees. And Z Thevenin is 3.415 plus J, 0.732 ohms. Okay, so we solved this problem before, and that's what we got for V Thevenin, I Norton, and Z Thevenin. I need to figure out that load value for maximum power transfer. What should it be? What should Z load be for maximum power transfer? It's the conjugate of Z Thevenin. What is that? Right, just flip the sign on the imaginary part. And then that power is V Thevenin. We're going to assume that this is RMS, by the way. I didn't tell you that, but we're going to assume RMS. Oh, I did say it. Assume source is RMS. So this is going to be the magnitude of V Thevenin RMS squared over 4RL. So Ian, are you matching now? Okay, so the magnitude of V Thevenin squared is 6.25 squared. RL is the real part of the load. So this is RL plus JXL. So RL is the real part of the load. So that would be 4 times 3.415. What is P max? 2.86 watts. Very good. Any questions?